So we have about another 25 minutes for questions. So as people have them and they come up, please do come up to the mics and ask your questions. So I'm going to kick things off just by thinking about this process of going from data to decision making. And it's something that both speakers touched upon in their respective talks. Ben, when you talked about the idea of vertical data science, you talked about quantifying uncertainty and just being very clear and transparent about where uncertainty comes from. So maybe I'll address this to you and then to Shek after, which is if you think about a doctor creating data that then gets fed into a model that then is used to make a prediction that is then used to make an action by another doctor. There's like this chain of events, each of which has some notion of uncertainty. How do you as a practitioner think about communicating that chain of action to the end user, the doctor? And what should they be sensitive to in terms of understanding and appreciating the uncertainty that comes with that?
That's a great question. So I've been struggling with kind of related questions. Like now I'm trying to introduce two additional sources of uncertainty from data cleaning and then model choices. So one question is, if I develop with my UCSF doctor collaborators, and I can make them to process data in one way, then that layer of uncertainty wouldn't be relevant. But I would feel like intuitively, if another hospital that I have no control how they clean their data, and my use of my algorithm, I would like to have the layer of uncertainty from the data cleaning. So that's, again, we have to write the documentation. So I'm saying that we should not give a generic uncertainty quantification. So the context of the future application should enter to play, and maybe we can give different layers of uncertainty. And for the doctors, and as much as we can, for the future users to say, hey, actually, I'm using a standardized data cleaning, and then I have a different intervals, which will be shorter than the ones who said, well, I'm going to do my own way. Of course, that might not be the one I considered, but at least would be closer to what this doctor will need. And so I think we have to be more refined about uncertainty quantification and really have an understanding about how trustworthy the uncertainty quantification and by whom.
So maybe just a quick follow-up to that. Like, if we ignore the hardness of computation of all of these uncertainties, we can ask ourselves, like, what is the perfect world that I want? Like, would you want a doctor to be able to decompose the uncertainty in terms of the action they're making into uncertainty for the legal risk that they're taking on, uncertainty for the financial risk? Okay.
Yes. I think I would need to have a refined sense of and define what's trustworthiness for what context.
Wonderful. So, I'm going to pass this along to you, Shek. And in the context of these large, vision, language, speech, genetics models that we're slowly starting to push out, does uncertainty matter? And in what sense how do we communicate uncertainty when there's so much information being fed into these things?
That's a very good question. I think I'm gonna echo also what Ben said. That we need a refined method of measuring it and communicating it and multiple level. That we have uncertainty that is coming from our data, and we have uncertainty that is introduced for our model. We are passing it to the next step of the chain. So I think having actually understanding around that uncertainty exists. Acknowledging it. That's very important step. Often we're gonna say that, I have 90% accuracy. We're just so good. But we never talk about things that they're surrounding of that 90%. That one of the factors is actually the uncertainty that is in the data and the prediction and the whole process that we have there. That's one way. The other way is that I think we're LLMs, VLMs, and if we overall calling them agents or agents getting smarter. So they have the communication capabilities, and I think we need to start to think about methods that actually bringing those capabilities so to get connected at the HCI level, basically, that human-computer interaction, that if we can communicate things very clearly using the actual language capabilities that these models they have, to doctors, to the user, and to go forward. The other ways to also like actually create barriers and like safeguards is that like we are talking about like augmenting doctors a lot or augmenting your like clinician a lot, which means that human is still like in the loop. So if we have like a huge failure because of this like accumulative uncertainty that we are introducing to the system, still human can like prevent it to cause like a disaster like down the line.
Wonderful. So, you know, just to summarize, the idea is that you want to think about both HCI elements that enable human experts to be able to query different reasoning modules as the model makes its prediction, rather than it just accepting the final answer as it is.
Yeah, definitely.
All right. So I know we had a few people lined up for questions. I want to give them a chance. Let's start here and then go on to that.
Dr. Azizi, so many of your models are hugely multimodal and bring together a lot of data sets, and so I'd just love to hear about the opportunities or challenges that you've run into when trying to get all of these different data types to work together. Like, do you see that having more modalities is always helpful, or are there ever cases where a model that was trained on one data type just has a hard time going to another one?
Yeah, definitely. I think like it's still like stitching all of these like modalities together is a bit of like more technical challenge, but like we know our way around these models. Like as an example, like at MedPalm-M era, like a year ago almost, like I think like when we were like developing that model, we actually were hitting a lot of issues on ingesting like mammograms, which we know that they are like very high resolution. We need to look at the local and global feature at the same time to make the decisions. And, but our context length at the time was like very limited. So whatever way that you're like patchifying that like information to fit it to the model is gonna cause issues or like break. The other challenge is that like you want to combine all of this information. We have like a bit of each like modalities, and like until now, I would say that like we don't have any automatic measure or way to actually decide about the proportion of the data that we are gonna introduce and the weight that we are gonna give to each models, and like how they're gonna like lead to new emerging behavior that we are like wants to achieve at the end of the day, but we are like very early on. So it's not clear that like how you should like approach that. A lot of time is just like basically trial and error. You're gonna fail and you're gonna see that, okay, this is not working, or we have like some benchmarks that they are somehow reliable, that you can use them to guide you, but at the end of the day, it's a lot still like staying on the table to be decided.
Thank you.
Hi, my question is for Binyu. So you talked about the stability part of the data analysis by looking all the ways that you can make different choices to see if your results are in some sense stable. And I was wondering how this relates to, for example, hyperparameter tuning, where this is actually quite opposite, where you try to use the fact that it's unstable, but there are local pockets where your model does quite well. So how should I consolidate these two views of building models?
Yeah, that's a good question. So when I started down the path of stability principle, definitely I was looking for stability. But over time, I also recognize that the first is really using stability. So I'm kind of broadening the stability principle. It's more taking at the stability angle. So hyperparameter tuning is a form of model selection in a way, right? In the particular, if you think a probability distribution is a more fixed model. So that will fall out under like stability consideration, and you can just more like follow the dimension of stability, think from that angle, and make it to your use. Either this is advantageous for you, actually want instability for exploration, right? Then that's a use of the other side of stability. And the other is, for exploration, I agree with you that it's really the instability, but to a certain extent. But it's really through the lens of the stability, I think has been productive for us. And you just give me an example that sometimes you want to look for instability, but also not too unstable, right? Because then you go crazy. So it's really what's the right amount of stability? Maybe I can reformulate what you're asking. Maybe not always the smaller the better. Does that answer your question?
Yeah, it does. Thank you.
Yeah, thank you.
So before we go to the next question, I think this is an interesting opportunity for Shek to react to this notion of stability. So just to set the context for this, you know, in large language models, and this was a couple of years ago, when you're asking it to answer question answers, you give it multiple choices, A, B, C, D. You can sort of permute the letters. You can, you know, do B, C, A, D, or you can even change the letters, turn it to J, F, K, L, M. And depending on what you do, your accuracy varies a significant degree. And so this goes back to the point that's been made about this notion of stability of the final result that you get. And it's clear that these models exhibit some notion of stability, but it's very different from what humans expect as stability. So I was wondering if you had any thoughts on, one, how we can understand the kind of stability that these models satisfy, and two, how we might be able to regularize or modify them to capture those notions better than they do now.
So stability is really an extension of the statistical sample sum variability in a way, right? But in a very broad sense. And when I was starting my first paper, stability was published 2013. I was really a modeler. I was just worried about. Over time, the last 10 years, I felt like even when we communicate, right, and you need linguistic stability, right? The word, when I was a graduate student, ML meant maximum likelihood. Right now, nobody knows that. So this is that even language, the basic foundation for us to communicate, have been evolving. So do we have enough temporal stability for us to have a meaningful conversation? And so you can also add stability. First, it's assessing stability, right? And say what's the right amount of stability we want for our particular problem, and for whom, right? The relevance. And then the question is, how can I bring my pipeline to satisfy that amount of stability? I just find stability a lot more flexible than the more precise variance and things like that to think about, because qualitatively, people understand stability in a very intuitive way. You have perturbation, something changed. But when you go to variance, you have the formula, and most people just said, well, you know, I don't know what you're doing. So that's what I try to bank on, is this qualitative sense and the human understanding of this basic. Life is about change, right? It's usually because stability, like perturbation. So I don't know whether you got at what you wanted.
So that's very interesting. Yeah, I really like that like example of like you need to have like a level of like a stability to even like keep a conversation like meaningful.
Yeah.
You don't want to like basically change like through the conversation, like change your direction or like your thought process. But like I don't think so that like we have like a method to actually measure thought process or say that okay, your thought process is just like, I don't know, like you're thinking about something like in like one direction. But like back to your question and like things that you made a like example of it. Like I think like maybe 2 years ago, the way that like these models, like LLMs per se, being like evaluated was like through multiple like data set and benchmark, that it was like important for us. And we knew that, okay, we want to reach some like accuracy on them, like for different topics and so on. And the way that we were like training our models was that, okay, let's fit all of these like multiple choice question to them or like question answer to them. And that definitely caused like issues. Like as you mentioned, that like if you look at the earlier models that we had, if you were like swapping like letters, the way that you actually even like presenting A, B, C, D with parentheses, without parentheses, with dash, without dash or anything, it can like basically result to like many like different answer or like accuracy. And like actually some methods been like produce like around that. We had like consistency method like coming after this like failure to like prevent it. That okay, let's run like one model with like different temperature, like different like reasoning paths, create all of the reasoning paths, like patch them together before like making a decision. But this is like very high cost. But like one of the other things that happen, I think like is a lot around like awareness of the failures and instability that it can happen to the system. And I think we had a lot of like good progress on the way that we are like training these large models. So we have like new techniques. We are like basically infusing like more and more diversity to the way that we are like training. There are awareness about like benchmarking more properly capabilities like in a more stable way rather than basically having them or like relying on some like multiple choice question. That's like one part of the problem. But like I think like we're still having this other type of like task that like having an instability is like useful for them. And there are like generative tasks that we want to have like innovation like in the way that we are generating. And like the way that is actually happening is like, for example, for large language models, like we are playing with or like temperature, or like in diffusion models when they are generating stuff, we are playing with a few of the parameters that we can actually make the model to create, be more creative and like give us like more like diverse range of things. But that really depends on the application that you want to use that like model for. When we are talking about like clinician and when we're talking about optimizing the clinical workflow or like summarizing the nurse hands-on and like many of these like example, I don't want to have like basically my answer or the way that I'm like summarizing things or like identifying important information to be changed. So we are like basically I think relying on the large range of application, and again, this is like emphasizing that we need better and better and better like benchmarks to be introduced to the way that we are like creating these models. So during training from like day one, we can actually prevent some of this like behavior that we don't want to see them like in our models.
Wonderful.
To add to that, I think actually the machine learning benchmarks, I would like to see that people use multiple metrics, especially subgroup, like type of metrics to really compare different models than just the average. I think especially for medical precision medicine, you not really care about the average performance, and that needs to become standard in a lot of the compared foundation models. Yeah, and that's kind of stability over different metrics. And it's kind of related to fairness as well, right? When you have different subgroups. And the transfer learning is also, I see it as part of stability considerations, just a transfer to another population. That's why I usually like basic principles that can be like manifested in different problems. And stability has been one of the principles that I kind of fell in love with for the last 10 years.
Wonderful. So we'll take a question here and then there.
So thank you for your presentation. My question is more about the future of this technology rather than the present mostly. So imagine that AI models are widely deployed in health applications. And as the health application progresses, these models need to gain new knowledge. Now, how much data do we need for the retraining of the models? How much resources are going to be spent? And whether can the models detect that they need to be relearned? Like a human can detect that something is strange. If something strange happens that is not explainable by the human's previous knowledge, they can detect that and they will retrain themselves. But can AI models also have that capability?
That's a very interesting question, I would say. So there are a lot of like, I think, thinking about like, even like beyond like medical domain about this like question. How I can like unlearn stuff, how I can like learn stuff, like new stuff, like, or like replace the knowledge that it was there with the new knowledge that we are like gaining. Like one way of like looking at it, like I think in clinical application, like we have like clinical guidelines. So that's just like changing like during the time and like we need to replace it. There are techniques that we can use, definitely, but still I think from the technical perspective, the way that we are like training these models and so on, there is like more to be done to actually doing this learning process, like continuous learning process, or if the failure is happening, the knowledge is changing more effectively. So we cannot like go back every time that there's something like new happening to like update a model that it has like billions of parameters. That's a reality that we are facing it for clinical application and for non-clinical application. And there is a lot of like awareness and research that is like happening around it. But I think the answer is like not clear now. Definitely humans gonna have a role for that purpose, that to provide also signals to the model back. So we're talking about a lot of like feedbacks and RLHFs and how basically human and computer can like interact properly and like effectively for things that they need to be like interacted. And but I would say that like that's is a bit of like unexplored land still.
Thank you.
All right, so my question is more towards Dr. Yu. Could perturbation and stability, can that be used to establish risk? And can we use it also as a tool for measuring biases with sensitive data or sensitive variables like race, sex, etc.?
So can you articulate what do you mean exactly by risk for the risk prediction?
Not race prediction, but like when you say like you would like to perturb the data in order to see if like you can shake it in controllable ways, so you can analyze whether the model remains stable even after you shake it up. Could that also be expanded towards like bias mitigation?
Bias is a tricky question, right? Bias is that usually you have something which is like a gold standard you can compare against. And the reality check through prediction in a way indirectly addresses bias, but not directly. Because you can have very good average performance. And the bias might still be there, but on average you're kind of okay. But on the individual level, you might have a problem. Of certain segment of the population, you might have a problem. So I would say that I haven't thought too much about it. It's an interesting question, but the question is I don't know. The answers right now. Bias, I struggle with how to estimate bias, and we had some project in causal inference, try to do that, and it's been very, very challenging to really, at the individual level, to get at the model bias, which is very important for like individual decision making if you talk about risk in that level. That's why I think the subgroup analysis, you still have enough aggregate information to check, but when you go to individual level, that becomes very challenging.
And this one's for Dr. Azizi. How have you, or how do you plan to evaluate your multimodal data model to the challenges of bias that can manifest in several ways, from like variances in imaging? And what benchmarks are on your mind?
Yeah. So for this is like everything is going back to like basically data, and like even like we're talking about like dealing with bias or just like measuring bias and so on. Well, like everything is going back to data. Like that was the reason that I mentioned that, like for example, we have like UK biobank, but like do we have like equivalent biobank from other places that they are actually covering other type of like ethnicity? So that's the reason that the data curation for some of these applications is actually like beyond one country, one region, and we need to increase the diversity of the problem, task, and like the data inside our data first, and then also like create a good benchmark to measure them. And like one of the like a famous ways to measure bias that it can happen to data is like a bias like in subgroups that it's been like around forever. That for example is like does my model like basically introducing like new type of like bias when we are detecting a skin condition. So we have like ways around like to measuring those type of bias that it can happen for like subgroups or the groups that they are like minority, and we know that okay, the model can fail there. And like many like examples that they are there, but everything's just like going back to, from the like starting the point zero, that like we need to actually correct our data set and the benchmark that we have, and then like go from there. And like some of it is actually with like increasing data in a meaningful fashion, in a way that is not bias itself, like training on the bias data from the first place. Then from there we can have like more smaller like benchmarks that we can actually measure the bias that you can like get introduced to the system for the factor that is like important for the task that we have. We are, for example, in clinical setup or like in like biomedicine overall, we are talking about like a lot of different tasks that we can like deal with different type of bias. So based on the task that we have, we need to identify benchmarks that they are relevant. Some of this is also like coming from like working with specialists in the task that we have. So if I want to design a model that is like working on a skin condition or like detecting like some sort of like heart failure or like it's like related to like kidney or like liver failure. So I definitely would have like basically talk and like get the knowledge from a lot of like specialists to actually understand that like what are the bias that we can introduce to the system. Because the answer is definitely changing from like one application to another application, and the way that we want to medicate it is completely like different.
Yeah, so come back. I think actually we have definitely a linguistic instability here. Being a statistician, when you said bias, I immediately thought it's the bias in the statistical sense. And hearing her answer, I realized you're probably talking about the bias of algorithm bias.
Yeah.
Is that what you meant?
Yeah.
Yeah, okay. So I was completely thinking about the wrong bias because the first reaction to me is what statistician calls bias. So on that, I do think the perturbation could help you in the sense that you can create, like, if you have ethnicity identities, you can actually change the proportions of the input data to your algorithm with different fractions of different ethnicities, and that's a perturbation. Then that might result, see whether the algorithm will change. And of course, you can also do synthetic data in some sense and create other synthetic but realistic perturbations to your input data set to assess whether your decision boundaries will change. So the answer is actually yes. For the perturbation for this type of bias, I think you can do things, but not the type of bias I was thinking about.
Great,
thank you.
All right.
Yeah.
We'll take one last, hopefully brief question from Rajesh. So.
All right. Yeah, it's a pretty brief question. It's related to both of the talks. So like in Bin's talk, there was like really careful statements about like the population where you could use a model. It was like, we can only do clinically significant prostate cancer assessment on those people who would have, or who are scheduled to get a biopsy, maybe that's the right way to put it. On the other hand, when we train these very, very big models, we kind of don't have an idea about like the data provenance, the coverage, and then getting more of it sometimes doesn't correct that for us. And so I could imagine a situation where somebody's like, hey, I have this great like model that works, it inputs genomics, maybe some like other stuff I know about prostate cancer. It gives me a score for like clinical significance, but somehow I've forgotten that this is only valid on the population that would have gotten biopsies, and that's some weird population mixed on the protocols across the world. And so how do you think about that when you use these like general models?
Yeah, that's an important question. Like I think like one important thing that we need to keep in mind is that like for large models, like it's just like are there LLM or like VLMs that we were talking about, or like multimodal models that we are seeing, or actually LLMs or like VLMs that they've been like adapted to like medical domain that they showed like multiple of them. At the end of the day, like evaluation, these are like proof of concept. capabilities that you can activate. And at the end of the day, the idea is that you're going to take that model and again, like adapt it to the environment that you want to like perform a task in it. So they are like exhibiting some sort of like general capabilities of performing some of these tasks. But for example, if I want to use like MedPalm-M and like take it for like report generation, extra report generation, which is like a very well established like task, all of us like we deal with it. And I want to like take that model, like using it, for example, like in India, which we know that like they have like actually using different formats of like report writing. Either we should like adapt it with a smaller number of like cases, so the model can like learn that, okay, what type of like information that they can like put up. And like, and basically using it for that environment. And like we never like talk about that, like, okay, we have like this generic model, let's take in like using it like around the world. If you're talking that like we're gonna have like prospective studies that they're gonna like actually looking at the model output and performance in like a very limited environment that we want to like work with it. But the argument is just like that, yeah, if you have like a generic model that it has a high capability to adapt to new environment with like less and less data, is a good sign. It means that like you can take it to new environment that you want to use it and like adapt it easily rather than like training a model from like a scratch that maybe is not like reaching the performance that you want. That's the argument. And like, for example, in the case of like chest X-ray that we have it, like for example, in MedPalm-M, we explored it like very in-depth, like in MedGemini paper. We have a very limited and like boundaried like experiment like environment. For example, we are testing our methods on like multiple type of data sets. Some of it, they are like open source data sets that you can just like access them. Some of them, they are like private data that we collected like around the world. And like we reported that, okay, what is the performance in each setup, where we are like failing. This is like a failure mode. We know that like, okay, we need to work on it. And like usually that's the way to go. And it's like a, I would say that like definitely we are exposing ourselves also like to more things that we need to do. It's like a easy setup at the end from the technical perspective that, yeah, I have a model that I can like adapt it here and there, but also is we need to like increase our like awareness of, okay, what I can like use for it or like how I need to like measure it. That's the difference. And like we can have like a scientific setup that, for example, I want to discover something. There, I definitely need a very limited environment that I actually can like probe things very carefully. So if I perturb this system, I know that, okay, what are the things that they are like changing through that system. So I think that's a difference of the basically things that we have like on the table.
So if I were to boil that down, you're telling me sample efficiency. You're like, I just need less sample efficiency, that I need like less data to do the adaptation, but sort of the validation parts of it remain similar, and maybe even like the scientific parts of it feel similar.
Yeah.
Thanks.
Maybe I can ask
Of course.
Shek a question
Concluding thoughts.
to follow on that question. So, I mean, when you guys put a model to the public, you must have internal criteria, because otherwise I'm sure you have some evaluation saying that now we're ready to put in the public. Can you share what are the guidelines, what are the dimensions and considerations you guys go through? Because I like to think you guys do that. I'm sure you do, but it's pretty opaque as a public to, like, extreme case, I would say that, like, a kid work on ChatGPT or something like that. It's like the formula keep changing. It's like take aspirin today, tomorrow the formula change, right? It's just very unsettling because we don't know the process. There's no FDA looking over your shoulders, and the public become consumption.
Yeah, short answer is that we are not putting this like sensitive model for the public use. That's like a very short answer. But the reality is that some of these models, they are for proof of concept. They are just like for like looking at the boundary of like what is the basically art of possible. Some of the models, they are actually getting to be served for the research community. And like for that, we have a lot of like actually boundaries around that, okay, who is like aware of the harm and like biases and like implication that is like coming with these models, and like what use cases these people, they want to use the model for it. For example, like TXLLM that I mentioned is like a drug related like model, is like a very sensitive model at the end of the day. If you can like use such a model to basically perform tasks that we don't want to actually being performed. And these are not like models such as like ChatGPT that we are just like putting it up there and like someone's gonna like write or just like play with the model. These are like very scientific, like restricted, bonded like type of model that it has a lot of like regulation and like testing also around them, that like who can use it for what purpose. And like when they are like, for example, some of these models, like MedPalm, for example, is being like served through Google Cloud, and for that we actually expanded at the, like a product front, that type of the benchmark that we have, type of the things that you can basically use that is like beyond like question answering, because like we know that like, yeah, question answer is just like good. It was a good like benchmark like 2 years ago, but it doesn't matter for the clinical setup. I'm like, for example, interested in like summarization tasks. So is it still like building up on like over it? But I would say that like these are not like really public data set, and definitely I think for everyone, like not like tech companies, I would say that like open weight models, for some of these models already have a lot of like implication coming with them, because they've been exposed to tons of like information that we are still don't know that how they can get used by operators.
Do you invite like academic like hackers to hack your system before you release it? Right, it's like a red team.
Yeah, I never thought about it. Never we had it. But like we are working with a lot of like academics to measure the performance of our model, or like basically use it in the setting that they have. We are working with hospitals for to like evaluate that, like to test drive the models that we are like building, and like identifying the failures that they can happen. But everything is still like at the research level. Definitely, and we need to have like a research lens to everything.
All right, I'm going to jump in. I think this is a good time for us to thank both of our speakers one last time before we head to coffee and then poster session, after which we'll have a networking reception. So thank you very, very much for an engaging discussion.